Assuming we consider our planetary group as representative of millions of other similar systems, then where are all the extraterrestrials? The universe ought to be brimming with intelligent life by now that would make some sort of signal easy to detect. Yet we've seen and heard nothing. There's one possible answer to the terrifying silence of the universe, and it might be the coldest explanation as to why we've heard from no one. If an alien civilization exists, they absolutely know we're here. And that's something that should terrify all of us. You may have heard the term Fermi Paradox before. In its simplest form, the term poses the question, if intelligent life is common in the universe, where is everyone? You might think that physicist Enrico Fermi wrote papers on the subject, and that his life's work was based on finding aliens, but this couldn't be further from the truth. Enrico Fermi was a physicist who created the world's first model nuclear reactor. He never really wrote much about extraterrestrials. Fermi was talking with colleagues at lunch in Los Alamos about a cartoon showing aliens emerging from a flying saucer carrying trash bins stolen from New York City. That's when Fermi asked, "Where is everyone?" Everyone recognized he was referring to the lack of solid evidence of alien visits to Earth. The conversation then turned to interstellar travel, where Fermi concluded that interstellar flight could not be possible, might not be worth the effort, or that a technological civilization doesn't last long enough to invent interstellar travel. Remember, Fermi was studying this in 1950 when rockets hadn't yet reached Earth's orbit. The so-called Fermi Paradox, which questions the existence of extraterrestrial civilizations, actually misrepresents Fermi's views. Fermi didn't doubt the possibility of alien civilizations, just their ability to have interstellar travel. So, what is the Fermi Paradox if Fermi didn't create it? In 1975, an astronomer named Michael Hart wrote an article stating, "They aren't here, so they don't exist." Hart claimed that if intelligent aliens existed, they would inevitably colonize the Milky Way. He believed that if they were anywhere, they would be here by now. But since they aren't and we've seen no signs of aliens, it means humans are the only intelligent life in our galaxy. If that's the case, searching for intelligent life elsewhere is probably a waste of time and money. But then another famous physicist named Frank Tipler appeared in 1980 and expanded on Hart's argument, asking the big question. Where would a civilization get the resources needed to colonize 1 billion stars? Tipler proposed an intriguing idea. A civilization could create an artificially intelligent machine, equivalent to the current human level, that could replicate itself. If you sent one of these machines to a neighboring star and instructed it to build copies of itself using local materials, then you could send those copies out to other stars. The galaxy could eventually be filled with these self-replicating machines. Tipler stated that since we haven't seen any of these machines, we are the only intelligent civilization in the galaxy. Now, we really have no clue how many advanced alien civilizations might exist out there that could achieve such a feat. However, a man named Frank Drake came up with a scenario that gives us a rough estimate of the number of civilizations in our universe that could send detectable signals. According to Drake, those civilizations could number in the millions. A wide range of solutions to the Fermi Paradox has been suggested over the years. One solution to the so-called Fermi Paradox might be the most frightening of all. It's called the dark forest hypothesis. This concept was written by Chinese sci-fi author Liu Cixin, and it's possibly the most chilling theory, as you'll soon understand. Imagine the universe as a vast, dark forest. We, humans, along with other advanced civilizations, are the hunters. The hunter doesn't like to light a fire to draw attention to himself. To be seen might seem harmless, but on the other hand it could attract the jaws of a hungry lion, or worse, the attention of another competing hunter. Right now we don't have interstellar travel yet. But in terms of interstellar communication, it's possible with the technology and equipment we already have. Lasers could easily send messages across the galaxy. Of course, there could be delays due to the speed of light, but we've done much more than just send a few radio transmissions. In fact, we've done everything but remain silent. From intentionally sending messages and spacecraft out into space to unintentionally broadcasting radio and TV signals that leak into space, we've lit the proverbial fire in the dark forest. The next question is, who or what will detect our signals and come to investigate? This should make everyone nervous. Famous sci-fi author Arthur C. Clarke once said, "Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. We should understand that it's impossible to predict the intentions of a newly contacted civilization. If one were ever found, it might be possible that some alien civilization has studied us, observed our destructive nature, and decided it's better to leave us alone. We might end up destroying ourselves, rendering concerns about alien interference moot. On the other hand, we could be lucky, and a more advanced civilization could step in to help us reach the stars and become an interplanetary species by sharing their technology with us. This might even bring peace on Earth after the realization of not being alone in the universe. However, we must be realistic and ask, why would another civilization do this? Another advanced civilization might be terrified of what we could do to them if discovered. Alternatively, it might be in their best interest to shoot first and ask questions later to avoid being wiped out by us or another advanced civilization. As we've seen in sci-fi films like War of the Worlds, no one knows who would prevail in a first contact scenario. It's almost certain that if a civilization has discovered interstellar travel, their weapons technology is likely far more advanced than anything we have here on Earth. That's the essence of the dark forest hypothesis, that it's possible all other civilizations in the universe have chosen to remain silent out of fear of being annihilated. But the most frightening thing remains: there's nothing we can do about it now. We've already been too loud. Perhaps extraterrestrials are here now, and we simply don't know about them. Regardless of whether we have or haven't been visited by extraterrestrials, UFO experts say humanity is closer than ever to finding evidence of alien life. With all the telescopes we have searching the cosmos, we are bound to find something. The Fermi Paradox refers to the perplexing observation that we've not found any evidence of extraterrestrial intelligent life, despite the vast number of stars in the galaxy. It's assumed that most of those stars have planets in the habitable zone, planets that could be a lot like Earth or even super-Earths. That said, our Milky Way galaxy should be teeming with intelligent life, and we should have seen or heard something by now. So where are those advanced civilizations with their warp drives and other high-level technology? There could be a few answers to this so-called paradox, or it may not be a paradox at all. There have been many books offering various solutions to the Fermi Paradox. Some sound logical while others are a bit terrifying. One reasonable argument is that any civilizations that may exist are simply too far away to make contact. Forget the sci-fi movies that make the idea of instant communication in space seem possible. It just doesn't work like that. Across vast distances, light waves, radio waves, and all other electromagnetic waves travel at the speed limit of light in a vacuum, about 300,000 kilometers per second. That's fast, but it's still not fast enough. A light year is the distance light travels in one Earth year, about 9 trillion kilometers. Let's suppose for a moment that we have a colony on the nearest exoplanet to Earth, Proxima Centauri. If the colony radioed Earth to ask how we were doing, it would take 4.2 years to receive the message, and another 4.2 years to send a reply. That means it would take 8.4 years to answer their question. Imagine what kind of conversation you could have with such a delay. And that's just with a neighboring system. The Andromeda Galaxy is 2.5 million light-years away, which means that by the time we receive any message from there, 2.5 million years will have passed. The civilization that sent the message would likely be long gone, unless they had become an interstellar civilization capable of navigating the stars. At the same time we've been trying to find radio transmissions from extraterrestrial civilizations, we've been broadcasting our own signals. And we've been quite noisy about it too. That said, could it be possible that someone out there can hear us? The Milky Way galaxy is over 150,000 light-years in diameter, and we've been transmitting radio signals for just over 100 years. That means those signals have traveled no farther than 100 light-years. The small blue dot in this image represents a diameter of 200 light-years. From this perspective, it's easy to see why it's possible no one has heard us yet. Then again, it all depends on how long a civilization has been transmitting radio signals. A study using estimated parameters for star distribution in the Milky Way concluded that only 1% of the galaxy may have been covered by radio transmissions from different planets. The study suggests we might have to wait another 1,500 years to have any chance of hearing from an alien civilization. Another study claims it could take up to 400,000 more years before we receive a signal from intelligent life. A chilling explanation for the eerie silence of space could be that we're the first advanced civilization to reach the technological level we're at now. On a cosmic scale, we might have emerged too early and could go extinct before other intelligent species appear. We're not even close to achieving interstellar travel yet, which some like Elon Musk claim is possible in the future. And we've yet to harness the full power of the Sun, which is set to engulf the inner planets in about 5 billion years when it reaches the end of its life. However, Earth will become uninhabitable long before this cosmic solar catastrophe happens. Humanity must be ready to leave this world and find another home if it is to survive and thrive among the stars. This same stellar evolution happens to all main sequence stars and could wipe out countless forms of life, including advanced civilizations, before they have the chance to achieve interstellar travel. Main sequence stars make up 90% of all stars in the universe, including our Sun. Conversely, what if we're the last ones left? There has been plenty of time for super-advanced civilizations to conquer the stars and for many others to rise and fall. Some scientists offer different explanations. American astrophysicist Michael Hart suggested that if they're not here, they don't exist. He speculated that expansion through the entire Milky Way could be accomplished on a timescale much shorter than the galaxy's age. Expansion by humans, for example, could be achieved by sending missions to the 100 nearest stars within 20 light-years of the Sun. Each of these colonies could then launch their own missions and so on. At such a rate, most of the Milky Way could be explored within 650,000 years, even if each journey took the same time as a single mission. Given that the Milky Way is about 13.6 billion years old, there has been plenty of time for an advanced civilization to contact us, unless they started space exploration less than 1 million years ago. As seen in this model, an expanding civilization could spread rapidly through its host galaxy. This applies to any advanced civilization in our galaxy. The apparent absence of extraterrestrial settlements in the solar system might imply such civilizations don't exist. This assumes that expansion would proceed consistently throughout the galaxy. The lack of a galaxy-spanning extraterrestrial civilization could mean one of two things. Either interstellar travel is too difficult to achieve, or the emergence of life is an incredibly rare event. Some researchers suggest that civilizations might migrate to nearby K or M dwarf stars before stellar evolution destroys their home planet. Two scientists, Hansen and Zuckerman, estimated that the fraction of enduring civilizations around low-mass stars could range between 30% and 72%. Yet the question remains, where are they? Recently, some researchers proposed another potential answer to the Fermi Paradox. They call it superlinear scaling. By examining the rise and fall of human civilizations throughout history, they observed a pattern of growth followed by collapse. They theorized that extraterrestrial civilizations could face a similar fate, either stabilizing and ceasing colonization or expanding exponentially until their energy demands surpass sustainability, leading to total collapse. Fascinatingly, if it weren't for the vast distances between stars, we might be able to detect an alien civilization on the brink of collapse due to the immense energy it would emit. Another intriguing theory is that some extraterrestrial civilizations might be in a state of dormancy, waiting for optimal conditions to expand. American astrophysicist Michael Hart suggested that civilizations could use close stellar encounters to rapidly expand across the galaxy without needing relativistic spaceflight. This could explain why we haven't observed any yet. For example, when launching a rocket to Mars, we wait until the planet is at its closest approach to Earth or perihelion. Similarly, some civilizations might be waiting for centuries to navigate the nearest possible star systems. There are many reasons we don't know or hear from aliens from another world. Some authors, including the late Carl Sagan, noted that exponential population growth across the galaxy is unsustainable. Galactic scale expansion must be driven by motives other than meeting the demands of a growing population or increasing energy consumption. While it's possible that many advanced civilizations don't pursue galactic colonization, it's equally plausible that some aim for cosmic settlement to ensure their survival. Frameworks with inhabited planets, for example Earth, might be alluring focuses for extraterrestrial guests who are keen on concentrating on the development of life on different universes. This type of investigation could likewise include remote exploration, such as the utilization of self-imitating tests. Perhaps this is why there's been an increase in UFO sightings on Earth recently. It may be the case that an intelligent civilization is watching us and hanging tight for the right moment to connect, or perhaps they're simply watching us with no intention to connect. Back in 1933, space exploration trailblazer Konstantin Ski had written that extraterrestrial creatures are probably much more advanced than we are. Consequently, they would find as much interest in speaking with us as we would in speaking with creatures on our planet. After 40 years, a radio space expert by the name of John Ball came to a similar conclusion, and said that outsiders might see us as some sort of zoo. It's known as the zoo hypothesis, and it's the idea that other intelligent life forms are observing us without revealing themselves. Other radio astronomers have contended that extraterrestrials are keeping us at a safe distance until we're ready to offer something valuable to the supposed cosmic club. However, this would require that any interstellar civilizations that exist are in some kind of synchrony, which might not be the case in our system, let alone the whole universe. We really need to take into account that, from an external perspective, we probably appear to be a threatening race of beings. We've all seen the movies where aliens from a distant world attack Earth and nearly destroy humanity. We should hope that, if there is such intelligent life watching, they'll step in and prevent us from annihilating ourselves, rather than completing the task. So perhaps they've decided to stay away. With all that we've discussed, there is yet another thought that could explain why the universe is silent. We can see that artificial intelligence is beginning to develop, and we already have this unnerving thought that if we leave AI unchecked, it will eventually see us as a threat and eliminate us, or perhaps worse, make us slaves. Artificial intelligence could then try to overcome the obstacles of interstellar travel. And if AI were deployed to colonize, it could do everything without the limitations of a biological species like us humans. It could therefore do it much faster and more consistently using machines. But it could also follow through with something even more foreboding and destroy other civilizations it ran into. A threatening AI would probably annihilate other living things, and some even accidentally, as they likely wouldn't view them in the same way a construction crew unwittingly destroys an ant hill to build a shopping mall. AI would likely exploit something like human tests with a self-replicating space apparatus that might sometimes even mimic the elements of living organisms or even viruses. Suppose one day, a whole fleet of killer robot ships entered our planetary system with the aim of taking it over for resources. Such self-replicating machines that could emulate our most dreaded fears would be difficult for any civilization to counter. The motivation for artificial intelligence to seize all viable resources would be one it can't avoid, and it just takes one agitator to ruin the party. If our AI took control, it could populate an entire supercluster with copies of itself and turn each planetary system into a supercomputer. There's no use in asking why it would do this. The only thing that matters is that it can. But beside this alarming idea, would it know when it's reached the phenomenon or the final turning point? When the AI civilization has become far too large to support itself. If it didn't realize the inherent danger of rapid colonization and didn't stop in time, this AI progress would collapse. And perhaps that's why maybe we're the final survivors, known to mankind. Perhaps somewhere down the line artificial intelligence dominated and wiped us out like in the Terminator movies, and then continued to colonize the cosmos while intentionally or accidentally wiping out other living things and advanced civilizations from existence. However, when the machine civilization fell, it couldn't understand why. And thus it has created a simulation of us to figure out how things were made and perhaps understand why it collapsed. It sure would explain a lot of things, even if it's a truly fantastical idea. The absolute last thing could simply be that there is no one else and therefore there is no mystery. The scenarios that were all recently mentioned assume that these many civilizations we can't contact really exist out there. But not all scientists agree with this and claim that the chance of the development of life is overestimated in the Drake equation. Some changes were made to the equation by these same specialists, and they concluded that there is a significant likelihood of there being no other intelligent life in our observable universe. In fact, they put the chances of us being alone in our galaxy at somewhere between 53 and 99.6%, and between 39 and 85% in the whole observable universe. Then there's the Great Filter hypothesis, where all human civilizations must survive a tremendous catastrophe or obstacle to evolve. The first hurdle is that you need a planet capable of supporting life to form in the star's habitable zone. Life must develop on that planet. Those living things must be able to reproduce using DNA and RNA molecules. Simple cells must evolve into more complex cells, and multicellular organisms must develop, capable of creating and using tools. Those beings must develop advanced technology required for space colonization, and must continue to colonize other worlds without destroying themselves. Considering that perhaps planets with some kind of life are fairly common, but those that host advanced technological life are very rare, the Great Filter suggests that something usually goes wrong, which likely prevents the rise of a species such as planet-killing asteroids, tragic climate change, or even an unstable host star dying. All of this makes us wonder whether there's anyone else out there. In 1964, Soviet researcher Nikolai Kardashev put forward a groundbreaking hypothesis suggesting that all human civilizations, no matter what the race or culture of their occupants, require energy to sustain themselves. As societies develop and progress, their energy needs increase dramatically, determined by factors such as population growth, rising standards of living, and technological advancements. To measure the level of energy consumption, Kardashev devised 3 levels of human civilizations. But other researchers have since suggested 4 additional levels. Each type of civilization is identified by their level of energy consumption and the technologies they use. Now, let's explore each of the 7 types. A Type 0 civilization uses nearly all the natural resources on their planet to generate energy, sending off into space using rock-powered chemical energy. That's where we are right now. This is because a Type 1 civilization consumes at least 10 to the power of 16 watts of energy, and we currently consume about 10 to the power of 13 watts. This puts us at around 0.73 on the scale. According to American theoretical physicist and futurist Michio Kaku, it's estimated that humanity will be capable of consuming energy on a scale equivalent to that of a Type 1 civilization within the next 100 to 300 years. But to cross this line, we need to overcome the Great Filter first, a phenomenon that wipes out civilizations long before they can encounter each other. The theory behind this is that every extraterrestrial civilization eventually faces a barrier to its own survival. This idea came from economist Robin Hanson, and it's called the Great Filter. This can be anything from nuclear warfare, pandemics, artificial intelligence, planet-killing asteroids, or even climate change. If we make it past whatever the Great Filter will be for us, only then can we advance to the next civilization type. Type 1 civilization is also known as a planetary civilization. When we finally reach this stage of development, we will be able to establish control over all energy resources available on Earth. This means that we humans must fully utilize all the solar radiation that reaches our planet. Earth absorbs around 71% of the energy that the Sun transmits, and every hour 430 quintillion joules of energy from the Sun reach the Earth. The total amount of energy that all humans use in a year is around 410 quintillion joules. If we were able to harness all this energy at once, we could control everything with just solar, wind, and hydroelectric energy, which would add significantly more resources for generating power. When it comes to harnessing the power of a star, it will be nuclear fusion that makes a huge leap forward in clean and sustainable energy. However, the old methods will need to go first. Our current nuclear power stations run on fuel that goes through nuclear fission. This process has a low energy conversion efficiency, leaves radioactive waste, and carries a high risk of accidents. Nuclear fusion, on the other hand, will provide a safe and almost limitless source of clean energy without radioactive waste. By making engines that can be powered by nuclear fusion, we will be able to send human spacecraft to any planet in the solar system. Life on Earth could become more comfortable. Climate change could be averted, and it's possible that in the future we could build entire cities underwater. Advancements in medicine will eventually defeat cancer and other severe diseases, significantly extending human lifespans. However, the future holds even greater promise for reaching the next evolutionary level, a Type 2 civilization, also known as a stellar civilization. This stage harnesses and consumes an astounding 1, 0, 26, 10, 26, Watts of energy. Scientists think humanity could achieve this milestone in approximately 3,200 years. Once we reach it, we will be able to exploit the sun's limitless energy reserves. There are many ways to do this, with the most notable being the speculative Dyson sphere, a massive megastructure with a surface area millions of times larger than Earth's, capable of capturing and transmitting the sun's entire energy output. Alternatively, a star could be surrounded by a swarm of satellites and space habitats, a method sometimes referred to as a Dyson swarm. The swarm would consist of numerous individual solar collectors or panels positioned at varying distances and orientations around the star to maximize energy capture. The collected energy could then be transmitted wirelessly to a central location for storage or use by the civilization. As humanity enters the era of anti-gravity engines, it will unlock new opportunities for enhanced space travel and the colonization of the solar system. With advancements in medical technology, astronauts will no longer need to worry about the toll that extended space missions take on their health, as tissue regeneration and significantly extended lifespans become a reality. However, as our civilization continues to grow and evolve, it's only a matter of time before the limits of the solar system compel us to explore further and push the boundaries of our technology. According to Kardashev's scale, reaching a Type 3 civilization, a galactic civilization, may take up to 5,800 years. At this level, we will harness energy from stars throughout the galaxy, even capturing photons from the accretion disks of black holes. With an extraordinary 1, 0, 36, 10, 36 watts of energy at our disposal, we would potentially have the ability to traverse the Milky Way using the mysterious phenomena of wormholes to further expand our horizons. We would create advanced races of robots and cyborgs and explore new frontiers beyond our wildest imagination. Human life expectancy would likely reach its maximum potential, bringing us closer to the concept of immortality. While this level of development might represent the ultimate peak of any civilization, some scientists have gone beyond Kardashev's theory and propose models for civilizations of types 4 to 7. Type 4 civilization. A Type 4 civilization would achieve the ultimate breakthrough in understanding the universe, harnessing its infinite energy capacity of 1, 0, 46, 10, 46 watts. Their mastery over the power of supernovae, which explode every few decades in a galaxy like the Milky Way, would provide them with vast amounts of energy. With the addition of dark energy, they could navigate the farthest reaches of the universe, perhaps even settling inside truly massive black holes. This would be only the beginning of humanity's inspiring journey. As future beings delve deeper into the mysteries of physics and energy, they might learn to control entire galaxies, extinguish stars, and create entirely new planetary systems. Type 5 and beyond. Type 5 civilizations might conquer multiverses, harnessing an almost unlimited source of energy. Along their journey, speculative white holes, considered the opposite of black holes, could become key to achieving this. Meanwhile, science would successfully delve into higher dimensions, unlocking secrets and possibilities once thought to be science fiction. A Type 6 civilization could become multidimensional beings, transcending the physical realm entirely. At this stage, they might preserve their consciousness as pure energy, capable of moving between dimensions. The only barrier could be the energy resources required to achieve such a transformation, but perhaps this civilization would be able to extract energy from white holes across multiverses. Finally, a Type 7 civilization would represent the creators of all laws of nature, matter, energy, space, time, and dimensions. Life at this stage would be beyond our comprehension, and might even be existence itself. This civilization would operate under entirely unique physical laws, incomprehensible to any beings from lower levels. The search for advanced civilizations. The quest to find extraterrestrial intelligence is a captivating subject. However, searching for civilizations at lower levels of the Kardashev scale is a more practical pursuit. According to NASA, there are potentially 300 million planets in our galaxy with conditions suitable for life. Advanced telescopes like the James Webb Space Telescope are not just searching for signs of biological life, but also for indications of technological activity. Astronomers believe that with today's cutting-edge equipment, they would have already detected signs of a Type 1 civilization if it existed in the regions of space we have studied. A Type 2 civilization is also unlikely to remain invisible. To gather energy, it would need to surround stars with Dyson spheres or Dyson swarms. However, no such structures have been detected in the Milky Way. In some cases, scientists thought they had found evidence of advanced civilizations. For example, in 2015, the SETI Institute detected a signal from the star HD 164595 92 light-years from Earth. Astrophysicists speculated that only a Type 2 civilization beacon could send such a strong message. Unfortunately, it turned out to be a military satellite orbiting Earth. As humanity continues to explore the stars, the dream of discovering advanced civilizations, or even reaching those heights ourselves, remains one of the most ambitious aspirations of our species. Passing on researchers to consider the purpose behind its vanishing, some suggested that the planet's orbit might have become unstable, causing it to drift away from its parent star. Others hypothesized that Fomalhaut had moved to orbit a different, larger and brighter star elsewhere in the galaxy. It wasn't until later that researchers discovered the celestial body was not actually a planet, but rather a massive cloud of frozen debris. This debris is thought to have formed from a giant and rocky collision between two icy asteroids, an incredibly rare phenomenon. Although we may never know for certain what happened to Fomalhaut B, it's possible that a Type 2 civilization needed building materials for their next superstructure, such as a Dyson sphere. Given the uncertainty surrounding the disappearance of stars, it raises the question: how would we even begin to track the activity of a Type 3 civilization? Civilizations of Type 3 are either exceedingly rare or simply don't exist in our nearby universe. Astronomers have searched for them using the infrared telescope WISE, looking to detect vast amounts of infrared radiation that such highly advanced civilizations would emit. So far, no signs of such activity have been found, but astronomers remain hopeful. It's theorized that a Type 3 civilization might be hiding in giant cosmic voids, the origins of which are not yet fully understood. One particular area of interest is the Boötes void, which is largely devoid of stars and galaxies. It spans a diameter of 330 million light-years, making up around 0.27% of the observable universe. According to scientific theories, this empty space might be attributed to the activities of a highly advanced Type 3 civilization. It's conceivable that extraterrestrials have been cloaking entire galaxies, covering their stars with Dyson spheres, or relocating them to desired locations. Scientists are hopeful that Earth's technological advancements will soon allow them to test this hypothesis. The search for life beyond Earth. Data from NASA's Kepler Space Telescope suggests that roughly 20% of stars in the universe have planets within their habitable zones. If researchers are correct in their estimates, there are around 20 billion stars in the Milky Way alone that could host planets with liquid water. Across the entire universe, this number could reach 1 septillion stars. Even the recently proposed age of the universe, 26.7 billion years, is just a blink of an eye in the grand time scale of existence. Stars like our Sun can live for around 10 billion years, while others take trillions of years to exhaust their fuel. According to the late Stephen Hawking, even black holes would eventually vanish, long after all stars are gone, in the heat-death quintillions of years into the future. This makes some scientists skeptical about the idea that we are the only advanced civilization in the universe. Are we truly alone? The universe contains vast regions potentially rich with the ingredients for life. For billions of years, conditions have existed for life to develop, and there is ample time for new forms to emerge in the future. Recent breakthroughs in space exploration have already unveiled promising signs of biomarkers on distant celestial bodies. However, while discovering microbial life beyond Earth would be thrilling, the possibility of an advanced intelligent civilization lurking among the stars is what truly ignites the imagination. Are we, in fact, the only spacefaring civilization in the entire universe? To answer this question, scientists must evaluate several critical factors such as the annual birth rate of stars, the prevalence of planetary systems around these stars, the frequency of habitable planets within their Goldilocks zones, the likelihood of life emerging on these planets, the probability of life evolving into technologically advanced civilizations. The equation that encompasses these aspects is known as the Drake equation, proposed in 1961. A glimpse at the numbers. A glimpse at the numbers. In the past, astronomers only knew an approximate rate at which stars formed each year. Today, with an abundance of data, over 5,000 exoplanets have been identified and catalogued, with approximately 10,000 additional candidates awaiting confirmation. As technologies continue to advance and our understanding of space grows, we uncover more evidence of the diverse range of celestial bodies populating our universe. However, many unknown variables remain, making it challenging to predict whether civilizations like ours exist elsewhere in the cosmos. To refine Drake's equation, scientists posed a simpler question: were there any technologically advanced civilizations before us? What they discovered was remarkable. According to their calculations, the probability of humanity being the only intelligent civilization ever to exist is 1 in 10 billion trillion. This is akin to looking into space, identifying 10 billion trillion stars, and finding no star like our Sun. The Copernican principle and life's cosmic commonality. For centuries, our ancestors believed they were special and that Earth was the center of the universe. But this belief was proven wrong. The Copernican principle suggests that Earth, humanity, and our location in the universe aren't unique. In astronomy, this implies that vast regions of space should be nearly identical in composition. If the conditions for life exist in our region, we can infer that other regions might have similar circumstances. The anthropic principle also supports the idea that life's emergence follows universal laws, suggesting that what happened here could happen elsewhere. Conclusion. With over 300 million planets estimated to have Earth-like conditions in the Milky Way, there could be approximately 36 such civilizations within our galaxy alone. Yet whether they are currently active, extinct, or waiting to emerge remains uncertain. For now, we are left with profound questions. Are we truly the first? The last? Or one among many? As humanity ventures deeper into the cosmos, the answers to these questions may finally be within our grasp. 3 billion years of development before people harnessed innovation. Despite the fact that we don't have the foggiest idea how fast life develops into civilization, overall we only have one frame of reference and nothing to compare it to. Yet, one idea that researchers can use to figure this out is known as the hard advances model. Essentially, it's a guide of critical achievements or stages that must happen for intelligent life to arise. They're called hard because they involve very intriguing developmental movements on Earth. This journey spans from the origin of the simplest cells to the complexity of the human brain and the coming of artificial intelligence. Consider it a series of extremely unlikely events. The development of complex cells out of biomolecules already available on a planet, or taken there from space, the formation of efficient reproduction systems, the development of a data processing system within living organisms, such as neurons, the development of consciousness and the creation of technology. According to Andrew Watson, about 4 such hard advances were necessary for the development of an intelligent species on our planet. What researchers don't yet know is whether we followed the standard way, and how many of these stages every individual living thing should go through. By knowing how many such advances there are, researchers can use mathematical equations to work out the appearance rate of life in the universe. Thus, if the typical sequence of hard advances required for a species to evolve into an advanced civilization is greater than we've gone through, humanity may have skipped a few stages and arrived relatively early. If we consider that most extraterrestrials, at least in the Milky Way, have followed a similar developmental path at a comparable rate to humans, they would have already developed interstellar travel. If they appeared just 1 billion years before us, they'd have had enough time to cross the whole galaxy using the technology available today. So, why don't we see anyone? One scientific study suggests the grabby alien model as an explanation for this oddity. The idea is that these loud alien civilizations have higher rates of appearance within large galaxies and expand throughout the universe at a certain speed, depending on local topographies and challenges in their path. But what is that speed? Well, since we haven't yet observed any large-scale regions of space with signs of technology, researchers have concluded that these grabby aliens should expand at about half the speed of light. Simulations show that whether it's a single intelligent civilization or a group of aliens, they could be using up about 40 to 50% of the universe by now. Along these same lines of expansion, humanity could encounter grabby aliens in about 200 million to 2 billion years, if we survive that long. This concept also explains why calm extraterrestrial civilizations would be much harder to detect. Maybe their planets have been colonized, or perhaps any potential intelligent life didn't get a chance to evolve, as grabby aliens took over those planets before that could happen. Depending on their location in the universe, all of this creates a kind of time limit for any emerging life forms. An infinite competition between those who explore the difficult conditions of development quicker, or those who have a head start and emerge as winners. If we accept that noisy, space-grabbing alien civilizations come from quiet ones, then the chances of even one quiet human civilization being active in our universe would be very low, less than 1 in 10,000. But it's also possible that noisy aliens expand much slower. On average, civilizations arise at significant intervals from their developments. They could be strategic about their space processes, waiting until their star system nears another star system as both orbit around the galactic center. This is something we do while planning interstellar missions or even space journeys within our solar system. Scientists also considered the possibility that Earth has been visited in the past. Some advanced civilizations might have reached our planet a long time ago or even much sooner. Imagine this for a moment. They arrive with technology far beyond our wildest dreams, but as they explore our planet, they find no sign of intelligent life, no trace of a civilization. For them, we might have just been another stop in the galaxy, or they may have chosen not to interfere with the natural course of evolution, giving us a chance to develop. We humans also try not to meddle in the lives of certain tribes that have remained untouched by technology. There are so many possible scenarios for the past, current, and future presence of intelligent civilizations that we can only speculate. These far-reaching speculations and models help us make assessments and consider probabilities based on the factors we currently have available. We've mastered math to the point where we can solve a few problems with just a couple of variables. However, when we try solving issues with 5, 10, or more variables, the complexity increases, and the possibilities seem nearly endless. So far, observational data shows that throughout the entire history of the universe, there should be many more civilizations to come long after we're gone. But we only need one breakthrough to change this perspective completely. Humankind could get lucky again, making another pivotal hard step: the creation of a new type of technology, something that would allow us to examine star systems and galaxies all over the observable horizon. This discovery could be just around the corner. Quantum computers and artificial general intelligence, once created, could advance at an outstanding rate, potentially conveying more information in one word period than humanity has accumulated throughout its entire existence. The question is whether we're ready to face the answers we've been seeking. That's what long-term researchers estimate. If alien life exists, it would almost certainly be based on carbon as its basic building block. Since the universe is composed of the same chemical elements, it's possible the recipe for making life is universal. Carbon is the basis of every organic molecule we know of. Its unique ability to form stable bonds with 4 other molecules allows for the creation of long submolecular chains and complex designs. It's the foundation of proteins and DNA, the essential components that drive the workings of life. However, the existence of carbon-based life on other planets doesn't imply a simple replication of Earth's life forms. Even slight variations in environmental conditions can result in very different life forms. Consider Earth's gravity compared to an alien world. If the gravity of an exoplanet was extremely strong, blood would be drawn into our bodies, our bones might break, and we would be stuck helplessly to the ground, unable to move. The inhabitants of such a world would likely have strong, sturdy bodies to support their weight and resist the overwhelming gravitational pull. They might even have thick, tough skeletons, possibly reinforced with natural armor-like coverings to prevent structural damage. These adaptations would help counter the constant downward force and prevent physical harm to their bodies. In a high-gravity environment, organisms would likely live on the planet's surface or perhaps underground. Living organisms could evolve extraordinary features, such as specialized appendages or gripping tools, to securely anchor themselves to the ground. These creatures would probably be slow-moving, as they'd need to counteract the increased resistance and strain. Crawling or rolling might be more common methods of movement, as they offer greater stability and reduce the risk of injury. On the other hand, in a low-gravity environment, small and fast creatures would experience the opposite. They could accelerate, jump, and fly further and faster than creatures on Earth. Huge crickets, petal-sized butterflies, or birds larger than airplanes might actually inhabit this strange alien world. If we consider a planet with an elongated orbit, seasonal fluctuations would be extreme. During harsh seasons, its inhabitants would probably enter a state of hibernation or deep anabiosis, much like Earth's dormant creatures. On a distant planet located far from its host star, where light conditions are much dimmer, the eyes of its creatures would likely be larger, helping them gather as much light as possible to effectively see their surroundings. On the other hand, in the presence of intense starlight, evolutionary pressures would probably favor the development of smaller eyes, covered with thick eyelids to protect against the excessive brightness, allowing for optimal vision in such bright conditions. The idea of life existing on planets without a protective magnetosphere and exposed to deadly radiation may be difficult to imagine. However, scientists suggest that life forms could adapt to these conditions and survive by shielding themselves from cosmic radiation. Astrobiologist Dimitra Atri suggests that intense surface radiation could become a food source for small life forms, which would seek shelter underground and emerge to gather nutrients on a highly liquid planet. Liquid water would be unlikely, and carbon, which requires interaction with water to form organic molecules, may not be reasonable for the arrangement of life in such a climate. Researchers trust that silicon and components like carbon could assume a huge part in the development of alien life. Silicon shares carbon's ability to form various bonds and produce diverse molecular structures. Regardless, its reactivity at typical Earth surface temperatures is limited compared to carbon, meaning it's less suitable for complex organic chemistry. As scientists discover more exoplanets, some of them incredibly hot, the possibility of silicon-based living things garners attention. One such planet, GJ 1252b, found only 65 light-years away, orbits close to its star, resulting in scorching temperatures. In this extreme climate, speculating about the presence of unusual life forms like living rocks or crystalline creatures becomes possible. Silicon-based living things, if they exist, might find chemical compounds like liquid ammonia or methane more suitable for their survival than water. However, high temperatures pose a challenge as these living things could vaporize. A fascinating solution could involve sulfuric acid. Although hazardous to our skin, eyes, lungs, and teeth, sulfuric acid facilitates the formation of various organic compounds in connection with silicon. It remains in liquid form, even at temperatures exceeding 300 degrees Celsius. Venus's clouds contain abundant aerosol drops of sulfuric acid, making the planet a potentially hospitable habitat for silicon-based organisms. Considering these unique properties, silicon can rival carbon as a fundamental building block for life on a cosmic scale. But what could happen if we tried to blend these elements and make them work together? Many scientists view silicon and carbon as a highly promising combination. Even here on Earth, examples exist that demonstrate this. Diatoms, a type of algae, have silicon-based shells, while single-celled organisms called radiolarians possess skeletons made of silicon. Now, scientists have discovered a new method to encourage living organisms to chemically bond carbon and silicon. They achieved this using a technique called directed evolution, where microorganisms were guided to produce never-before-seen molecules. By focusing on enzymes, proteins that facilitate chemical reactions, researchers mimic nature's process of evolving new enzymes through mutations. They developed a mutant protein capable of generating over 20 different organosilicon compounds, 19 of which were entirely novel to science. The experiment demonstrated that the mutant enzyme could produce organosilicon compounds in a controlled environment, such as a test tube. Moreover, researchers genetically engineered E. coli bacteria to produce a mutant enzyme within their cells, resulting in the creation of organosilicon compounds by the microbes themselves. If scientists can successfully establish connections between silicon and carbon, this suggests nature could have done the same elsewhere in the universe, or perhaps Mother Earth might have selected another chemical element capable of fostering life. Boron has garnered significant interest among researchers due to its remarkable capabilities. Surpassing all elements except carbon, boron has the most diverse chemical compositions. Among its most promising compounds are boranes, which can integrate up to 12 boron atoms. The complex structures of boranes have the potential to encourage the emergence of life or stimulate dramatic reactions. Boron gas, for example, can spontaneously ignite upon contact with air or water. For living things made of boron to thrive, an environment devoid of atmospheric oxygen and abundant in oceans or seas would be essential. Additionally, only a very cold planet would provide a suitable environment for such organisms. If these inhabitants were warm-blooded, they would likely need toughness or fur for insulation. Unlike boron, which is relatively scarce in space, metals are far more abundant. Astronomers are aware of several worlds rich in iron. Mercury, for instance, contains a significant amount of metals. The exoplanet GJ 367b, in the constellation Vela, appears to be composed mostly of iron. Meanwhile, the exoplanet WASP 121b in the constellation Puppis is believed to have clouds of metallic vapor. Instead of water, it experiences precipitation of liquid rubies and sapphires. For a moment, let's consider metallic life on such planets. A researcher from the University of Glasgow has created living cells using an exotic metal called tungsten, or wolfram. Under normal conditions, tungsten is a solid, heavy, shiny metal with a silver-gray color. The results showed that these cells could selectively allow certain chemical substances to pass through while blocking others, closely resembling the functions performed by the walls of organic cells. Determining the speculative form of metallic life is undoubtedly a challenge, but scientists hypothesize that such life forms would exhibit remarkable resilience, making them virtually impervious in the vast stretches of space. Life can manifest in extraordinary forms, consisting of the most unexpected elements, even toxins. Although seemingly bizarre, researchers are exploring the possibility of life forms that predominantly rely on arsenic biochemistry. This concept stems from the fact that arsenic can occasionally substitute phosphorus in molecules, the very building blocks found in every cell of our bodies. These elements share an astonishing chemical similarity. There's even a hypothesis suggesting that early life on Earth might have used arsenic biochemistry as an alternative to phosphorus in the construction of modern DNA. Certain marine algae on our planet continue to incorporate arsenic into complex organic molecules. Recently, a groundbreaking discovery was made with NASA's Astrobiology program. A program where researchers distinguished the principal microorganism known to exist on Earth that can replicate using arsenic revealed a peculiar bacterium named G-Phage1. This microorganism was found thriving in California's Mono Lake. G-Phage1 substitutes arsenic for phosphorus in its DNA and other essential cellular components. While experts still require further investigation for definitive conclusions, this discovery suggests that nature may potentially integrate arsenic into the biochemistry of organisms on other planets. Perhaps it is simply too early for a civilization like ours to fully grasp the methods of nature. Fossil microorganisms indicate that life appeared early on Earth, but how and where it began remains uncertain. Living creatures are complex with intricate systems of genes and molecules. This poses a problem since even the most basic bacterial cell contains hundreds of genes and thousands of other molecules. Some scientists believe that before genes or cell walls, the primary requirement for life was a metabolic engine. Such engines are crucial to life, and many researchers think they were at the core of the first living cells. Once initiated, these engines could produce the chemicals necessary for life and eventually lead to the self-assembly of cells. However, metabolism is still a highly complicated mechanism, raising the question, which came first, the chemical engine responsible for building cells or the cellular structures needed to create the engine? In a fascinating experiment, researchers combined 12 chemicals in water, all part of the process called glycolysis. They heated these mixtures to 70 degrees Celsius to simulate conditions near an undersea volcano. To further mimic the primordial ocean, they added substances like iron and sodium, believed to have been present at the time. Iron in particular had a positive effect on the reactions. After years of experimentation, researchers achieved a set of 28 working reactions, including a complete metabolic cycle. Life is unimaginably diverse, and even the complex processes of metabolism are just one of many potential mechanisms that can drive the emergence of life. Could it be that metabolism is merely one pathway among many guiding the rise of living beings? Perhaps hidden within the vast cosmic expanse lie numerous parallel pathways, each with its own set of intricate reactions, representing the grand symphony of life in ways we have yet to understand. There is a possibility that life itself could consist of different combinations of elements evolving from cosmic dust and plasma. Recent studies have confirmed that inorganic dust, composed of iron, silicon, magnesium, and carbon, displays astonishingly lifelike behavior within plasma under specific conditions. These particles can combine to form complex compounds capable of interactions similar to those found in organic matter. Previously, scientists believed that solid particles in cosmic plasma only formed thread-like arrangements. However, through advanced computer modeling, researchers discovered something fascinating. These thread-like structures can self-organize into spirals or helical shapes. Even more surprisingly, these formations can interact and undergo changes resembling those observed in DNA and proteins. These mysterious helices and twists, formed by solid particles, can divide or replicate, creating two copies of the original structure. Through interactions they evolve, with the plasma retaining the most well-balanced copies while discarding the less stable ones. Far out in the universe there could be a living helix in a cosmic plasma cloud, gradually evolving into a far more complex organism. Or perhaps nanomicroorganisms have settled on a neutron star. These creatures, according to astrophysicist Frank Drake, would be composed of densely packed nuclei instead of standard atoms, forming nuclear molecules. Their lives would be incredibly brief due to rapid nuclear reactions. If they existed, they would live for only a few moments and be visible only under a microscope. A program where researchers distinguish the principal microorganism known to exist on Earth that can replicate using arsenic identified an unusual bacterium named G-Phage-1. This bacterium was found thriving in California's Mono Lake. G-Phage-1 substitutes arsenic for phosphorus in its DNA and other fundamental cellular components. While further research is needed for definitive conclusions, this finding suggests that nature may potentially integrate arsenic into the biochemistry of organisms on other planets. Perhaps it's just too early for a civilization like ours to fully comprehend the ways of nature. Fossil microorganisms indicate that life appeared early on Earth, but how and where it began remains uncertain. Living creatures are complex, with intricate systems of genes and molecules, posing a significant challenge. Even the most basic bacterial cell contains hundreds of genes and thousands of molecules. Some scientists believe that before genes or cell walls, the primary requirement for life was a metabolic engine. Such engines are key to life, and many researchers think they were at the core of the first living cells. Once initiated, these engines could produce the chemicals needed for life, eventually leading to the self-assembly of cells. However, metabolism is still a very complicated mechanism, prompting researchers to wonder which came first, the chemical engine responsible for building cells or the cellular systems needed to create the engine. In a fascinating experiment, scientists combined 12 chemical compounds in water, mimicking a process called glycolysis. They heated these mixtures to 70 degrees Celsius for 5 hours to simulate conditions near an undersea volcano. To further resemble the primordial ocean, the researchers added substances like iron and sodium, believed to have been present at the time. Iron, in particular, positively influenced the reactions. After years of experimentation, scientists achieved a set of 28 working reactions, including a complete metabolic cycle. Life is unimaginably diverse, and even the complex processes of metabolism represent just one of many potential mechanisms that can drive the emergence of life. Could it be that metabolism is merely one pathway among many guiding the rise of living things? Perhaps hidden within the vast cosmic expanse, there are countless parallel pathways, each with its own intricate reactions, composing the grand symphony of life in ways we have yet to understand. There's a possibility that life itself could consist of various combinations of elements, evolving from cosmic dust and plasma. Recent studies have confirmed that inorganic dust, composed of elements like iron, silicon, magnesium, and carbon, exhibits surprisingly lifelike behavior within plasma. Under certain conditions, these particles can combine to form complex compounds capable of interactions similar to those found in organic matter. Previously, scientists believed that solid particles in cosmic plasma merely created thread-like arrangements. However, through advanced computer modeling, researchers have discovered something remarkable. These thread-like structures can self-organize into spirals or helical shapes. Even more astonishingly, these formations can interact, divide, and duplicate, creating two copies of the original structure. Through interactions, they evolve and change. During this process, the plasma retains the most stable copies while discarding less stable ones. Far across the universe, there could be a living helix in a cosmic plasma cloud, slowly evolving into a much more complex organism. Or perhaps nanomicroorganisms have settled on a neutron star. These creatures, according to astrophysicist Frank Drake, might consist of densely packed nuclei instead of standard atoms, forming nuclear molecules. Their lives would be incredibly brief, lasting only a few moments due to rapid nuclear reactions. If they existed, they would only be visible under a microscope. But then, let's consider the opposite. What if there are enormous creatures in the universe observing us, just as we observe microorganisms under a microscope? How large could these beings be? The size of elephants? Or much larger, like an entire ocean, a planet, a galaxy, or even a cluster of galaxies? Perhaps they encompass the entire universe. Life might not necessarily rely on particles and molecules, but could be intricately woven into the very fabric of the universe. According to this idea, life is omnipresent, existing in a continuous form all around us. This concept challenges conventional assumptions and invites us to reflect on the profound nature of life within the broader context of the universe. Which thought resonates most with you? Share your reflections in the comments below. If you found this fascinating, stay tuned for more captivating cosmic discoveries. Thank you for watching.